So in this video, I will talk about model evaluation with resampling. And we will do our applications in Python and by using this Google Colab. And if you go and just write colab.google, then you will see this collaborative page. And it is just, you can just able to execute your Python code in your browser in here. And first thing we will do is that we just open a new notebook and then go with that notebook in here. So I have my, and first thing we will do is we are just importing some libraries in here. And here are the libraries we will use for today. Maybe you notice that mainly we use Kite-Learning in this application. And we run this part. And first thing we will do is that we are going to load the data set. Let's say I want to load my data. And for this example, we will use iris data set. And we run this. And so iris, maybe you remember the iris data set. And it's just give the measurements in centimeters of the variables, sepal length and sepal width, petal length and petal width for 50 flowers. And we have that 3 spaces, which are Setosa, Versicolor, and Virginia for these data sets. And so our target variable is just these spaces. And by using some clustering method, we are trying to guess these spaces by looking at our explanatory variables, which are sepal length and width, and petal length and width in here. And let's continue with first method we use today. And the first one is just holdout method. Let's say I want to use holdout. And first thing we will do is that, please remember in holdout, we were just splitting our data set into 2 parts as training and test data. And first thing we will do that, we are just using this training data to model, to train our model and just test with test data set. So to do that, we are going to use split function in Python. Let's see what I mean. And here is our X training and X test and Y training and Y test. And please keep in mind that Python already knows that our target variable is the Y is the spaces in here. And we are just splitting our function, our data set by using this function in here. And please keep in mind that it just split arrays or matrices into random train and test subsets in here. And that's why we have random state. And I just wrote 33, you can just play with that part. And then just write 33 to have the same results. And test size is 0.2 in here. That means the 80% of the data set is just training and 20% is used for test data sets. And in here for clustering, we will use KNN. And please remember that to implement this method you should first standardize your data sets in here. But it's kind of easy in Python. Let's see how can we run that one. And we will use standardization. And there is one function in Python you can use for this. And here is what. You just standardize your features by removing the mean and scaling to unit variance in here. Okay, and you can just find the formulation in this help file. And here is what we are just standardizing our training and test data separately in here. And after that, we are good to go with KNN, that means K-neighbors classification. And here is the function we will use in here, KNN neighbor classification, and just implement the K nearest neighborhood. Please remember that K is just hyperparameter. And you can just define here. And I think the default is 10, but for this example, we define it as 5. And weight is just the function used in prediction. If you write uniform, like in here, and that means all points in each neighborhood are weighted equally. And P is just an integer, and that's the power parameter for the Minkowski metric we will use for our classification method. And since we write P as 2, that means we are going to use Euclidean distance. If it was 1, then it is just Manhattan distance in here. And this is our metric, which can be used for the tree. And n-job means if we implement that in parallel or not, that when we write 1, that means we are not running that one in a parallel manner, okay? First thing I will do is that I want to just KNN, I want to just use KNN to model training. Let's see what I mean. Here is the command we will use. By using our training X and Y's, we will just fit the model first and see how our predictions work for this model, okay? And maybe you see that we are using this guy, the KNN in here, and just using the fit to train our data. And then we will just see the predictions by using X test. And after that, we should get the performance values of that KNN. Here it's up. When we write KNN.score, it's just going to give us the performance of our test in here. And we may want to print that part. Let's run. And we implemented that part, and you see that the 80% of the times our predictions are true in here, okay? And maybe the accuracy of our model is just 80% for this example. And maybe you may want to increase this accuracy by using more sophisticated methods in here. And one of them is repeated holdout, okay? Let's see, I want to use this repeated holdout. Okay. So this time we are going to repeat this training and test splitting part and run our KNN for several times. And it is, please keep in mind that it's just an iterative work in here, okay? And first thing I will do is that I will just define my model. Here is my model. Okay, I give it a name as T/KNN, and then I have K-neighbor classifier as before. This is just same as before in here. The name is only the name is different, or you can just use this guy too. Okay, and so I want to repeat this one and 50 times in here. And I want to save accuracy in here, okay? This is an empty vector now, but I want to just fill this accuracy by running my classification method several times, and more specifically, it is 50 times in this example. And please keep in mind that it is an iterative work in here, and we can just use for loops for the range of these repeats, and just split our data set as in here several times in these for loops, okay? And for each data set, we will just repeat each steps in here, okay? Let me just get this part for loop. And here is what. For I in this range in here, and we are just splitting our data sets into test and training. This time we are using 70% instead of 80. And you see that we are just changing I in here. It's going to go from 1 to 50. And that means for each random splitting, we are going to have different training and different test data sets, okay? And after that, after splitting our data set, we will just standardize our X values, and then we will use our KNN to fit our model and just get the accuracy by using test data sets and just append each value to this vector, okay? And let's run this part. Okie dokie. So we want to print that accuracy actually after we run that one. And now our performance for repeated holdout is 69%, 0.69. That means we just increase the performance of our classification by using repeated holdout in here. Okay, this is what we are just trying to do in here. So the other method for today, we will use k-fold cross-validation. Let's start with k-fold cross-validation this time. And first of all, we will just define some hyperparameters in here as a range from 1 to 20. Okay. And first thing we will do to get training and test data set after hyperparameters. And we have 0.2 for test size. And please remember, if we are going to use KNN as a classification method, we should do data standardization as usual. This time, there's something different. We should just generate a cross-validation object in here. So let's see how it is going to work. And here is how we are just generating cross-validation object in here. And split is the number of folds. That means we have 10 folds in here. And this just and please remember, we should shuffle every time when we do that in this method, okay? And after that, we want to generate some vectors that we kept some model informations in here. Let's generate the vectors in here, and they are going to kept the model information, okay? Let's see what I mean. We are going to just use this accuracy, and maybe you can just save standard deviation and standard errors in here. And for each of these hyperparameters, we are going to just run our KNN, okay? And then just say some MSC values in here, and then accuracy measurements for us in this example. Let me first just put the for loop in here, and then we will talk about it. And you see that for each hyperparameters in here, for k in 1 to 20, you remember that part. And we are just running this k neighbors classifier. And you see that this k is going to change for each for loop. But please notice that inside that for loop, we also have one more for loop in here, and just get some values in here. And this part is same as before. We are just running k-neighbors classifier by using the same parameters we used before. And this is going to be run for each k in here, that from 1 neighbors to 20 neighbors in here. And we just save we just generate an empty MSC. And inside that loop, we have one more loop. First of all, by using this k-fold function in here, we are having our X training and Y training, just splitting that part as training index and validation index in here. And our estimation is coming from that classifier, please remember that one, and just training our model with only this data set in here. And for each of them, okay, we have different training and validation index. For each of them, we are just running our model and just get the predictions from here as estimations, okay? We are just using this training training X and Y, and just using these validation indexes, we are having our predictions, okay? And this is our MSE cross validation in here. And maybe you see that we have our actual values as Y, and then we have estimations. By looking at them, we can find our MSE cross validation and just append all of them. And after this for loop, you are just get out of this for loop, and then we are done in here, okay? And when you see a blank in Python, that means you just get out of that part in Python. And now we have our MSE, and then we will just find the mean value for this MSE and standard deviation in here, and also standard error in that example, okay? And after that, we are able to find the accuracy and just find the standard deviation for that one too, and also for standard error. And by looking at this part, when we are just out of for loop, okay, by looking at this part, we can just find the best K. That means it's making our accuracy the maximum one. And when we run this part, the whole part, you will just see, maybe we will just find our best K in here, and let's print our best K. Let's run it one more. And our best K for this model is 3, and we will just run this new model with this best K and tune with test data in here. Okay, this is just tuning part. So maybe you see that now we have again the K-neighbors classifier in here, and instead of all K's, we just use a specific K, which is the best one, and it is 3 for this example. And we again run this part and fit our model by using this training data set. And please keep in mind that this is never seen before. And this is just a test data we never use in here. And we have train and validation test and test data sets. And we just run this new model and tuning and this part with test data set in here. And just find the accuracy in here. And after that, we are going to use all data for the final model, okay? And let's say I'm just going to use all data set for final model. And here is our final model. We have our X, which is whole data set. And we have our KNN model. Now we are just running this part with whole data set. And then we are able to see our performance in here. It is 0.96, and the performance of our close validation in this example. So to increase the accuracy of this performance or the accuracy of the model, we can also try repeated k-fold in Python. Let's say I have my repeated k-fold cross validation this time. Now, again, I will just try different hyperparameters from 1 to 20 and just save general accuracy and cross validation accuracy in here. Please remember, the first thing we do is that we just split the data set into training and test as a first step, and then just standardize our values by using that standard scalar in Python, okay? And after that, we will just repeat the previous job that we have run in this k-fold in here. Do you remember that? We just use that k-fold function by shuffling in here to split the data set. But this time we are going to repeat that part in repeated k-fold. Say I have my repeats as 5. So we will just use the same guy, same job in here for our repeated k-fold and just use the for loop and repeat that part 5 times in this example, okay? And let's see what I mean. So we have our for loop again, and this time instead of 2, we have 3 consecutive for loops. And you already know this part, what was happening in here, and also you already know that part too. For each hyperparameters, we were just checking for our classification method and just use this guy inside our for loop for each training and validation test and see the MSE values and just save our hyperparameters accuracies and the general accuracies in here. Okay, we are going to saving different parameters and then we will find the best K in this example. But this time, and just out loop, we have one outer loop in here, and this shuffling part is just repeated 5 times in this example, okay? And at the end, I want to just get the best K in this example, okay? By using this one, I want to get, by looking at this hyperparameters general accuracy in here and the mean values of them, I want to just get the maximum one. Okay. And it will take some time, but not that much. And maybe we can just print K this time. And slow dash. Let me run this part one more time. And now the best K looks like 0. And let me run it one time. Yeah, it seems like 0 in this example. And so we will run the new model with best K in here. And so how it is possible to be 0? Let's see. We have different hyperparameters in here. And then we have that one from 1 to 20. And let's run this part one more time. And a 0. And let's see this key. Oh, actually it is just giving the place of the K, and we should get, if we want to see the K value in here, and maybe you remember that the index in Python is starting from 0, different than R, and R is just starts with 1. And we can just use the index in here, the best K index. And just now, instead of this one, we can find that one by using this index. And I just and okay. And one is seem that it is the best K in here. And now we are going to just run new model with best K and tuning with standardized this training data set in here. Okay, let's just run this part. And so we will use this best K as our hyperparameter in this final KNN and just use this training and test data sets. And at the end of today, we want to use all data set, okay? Just run this part, it's just giving accuracy. And at the end of the day, I want to use whole data sets to not this one, maybe we are going to use the whole data set. in here and see the performance of our close validation. Yeah, wow, it is kind of overfitting. And here is what we have done so far. We just used that Skylearn library in Python to use this model evaluation with resampling methods in here. And we started with holdout method and then use repeated holdout, which may be more preferable. And then we use k-fold cross-validation. And after that, we use repeated k-fold cross-validation in here, but just repeated k-fold gave kind of an overfitting in here. And this is all I want to do about application in Python for today.